Hello students. So today we will discuss about major and minor losses. So for that I am sharing this screen with you. So initially we will discuss about syllabus, that in flow through pipe, which are the topic you will have to cover. So here you can see that flow through pipe, initially we have major and minor energy losses. Then after hydraulic gradient and total energy lines, pipe in series and parallel, equivalent pipe and water hammer in pipe. So these are the topic we will cover for flow through pipe. Now in that, initially we will cover major losses and minor losses. So we should know that what is difference between major losses and minor loss. So basically major loss means loss occurred due to friction. Loss occurred basically due to friction, so that will be known as major loss. And minor loss means in pipeline, suppose there is a bend in pipeline, suppose this is the direction of flow and suddenly there is a bend, so at that time some energy loss occurred. So suppose in pipeline there is a sudden expansion in pipeline, so then also energy lost occur. So if sudden contraction, so then also energy get lost. So this is basically difference between major loss and minor loss. Major loss means it is a loss because of friction, and minor means it is a physical, related with the physical term of pipes. So in major loss, basically two equations are being used: Darcy's equation and Chase's equation. So we will cover all. So first is Darcy's equation and Chase's equation. So I will cover both. But in this lecture, in this video, we will majorly cover Darcy's equation for friction. So suppose we want to find out energy loss in pipeline due to friction, so we can find out by use of this equation. બરાબર, આપણે એનર્જી લોસ ફાઇન્ડ આઉટ કરવું હોય તો આ ઇક્વેશનની મદદથી આપણે એનર્જી લોસ ફાઇન્ડ આઉટ કરી શકીએ. એનર્જી લોસ કોના લીધે થાય છે? ઇટ ઇઝ બિકોઝ ઓફ ફ્રિક્શન. સો ફોર દેટ you will have to take here one pipeline. So let us assume here we have one pipeline, and in pipeline you will have to assume this section. Here we have one of the section, so here you will have to take this section. Now let us take this point as a 1 and let us take this point as a 2. Clear? So here we can see flow is taking place. Now initially we will have to apply Bernoulli equation. Here we will have to apply Bernoulli equation. So what will be the Bernoulli equation? P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 plus HF. Now HF means head loss due to friction. So here we can see that there is no potential difference between these, so this will be get cancelled. So here also there will be a minor change in velocity, so these also you can cancel. So what will be the equation? That P1 minus P2 divided by rho g is equal to HF. So this is our first equation. So let us give it as a equation A. Now then after we will have to apply, initially we have applied Bernoulli's equation. Here we have applied Bernoulli's equation. So now we will apply force balance. So these two equation you will have to use force balance. So here which are the force that is basically apply or applicable here? Now here we can see that here we have pressure P1 બરાબર ને, અહીંયા પ્રેશર P1 હશે. અને આને જો 3D માં જોઈએ તો આ રીતે આપણે સેક્શન લઈએ તો P1 કઈ જગ્યાએથી લાગશે, અહીંયાથી લાગશે P1. તો P1 પણ અહીંયા આપણે ફોર્સ ફાઇન્ડ આઉટ કરવાનો છે. તો ફોર્સ એટલે પ્રેશર ઇન્ટુ એરિયા. તો અહીંયા જે થશે તમારું P1 ઇન્ટુ એરિયા શું થશે તમારું, pi/4 d1 square. Clear? Now then after, or let us tell it as a A1 or AC, area of cross section. Let us write down area of cross section. Clear? Now another force will be applicable in another or opposite direction. So P2 also will be applicable, but P2 will be applicable in another direction. So we will have to take P2 here into cross section. Now another force is applicable, and that is frictional force. So that is also in opposite direction, but what is the equation of that? Now equation is according to Frod's law. This is the equation, frictional coefficient, then after area. Now on which area this friction force applicable? Here you can see that in this area. So this area is known as pi dl into v square, velocity square. Clear? So this is equation according to force balance. Now here let us take P1 minus P2 into area of cross section. Here we have equation pi dl into v square. Now ultimately what we will have to find out, P1 minus P2 is equal to f dash into pi dl into v square. Now here area of cross section. So I told you that what is equation for area of cross section. Here basically you will have to write AC, area of cross section, but we know that what is equation of AC, pi/4 d square. So here you will have to write pi/4 into d square. Clear? So this is our basically, here we have 4. It was not written properly, but it is 4. Clear? So pi get cancelled, d also get cancelled. So what is the equation? F dash, then after L v square 4 into d. So this is equation. So this is equation for P1 by P2. So now let us give this equation as a equation B. So this is our equation B. Now we will have to compare equation A and equation B. So here you can see that equation A and equation B. So according to equation A, what is P1 minus P2? P1 minus P2 is equal to HF into rho g. This is the equation. According to equation A, P1 minus P2 is equal to HF into rho g. And what is according to force balance? P1 minus P2 is equal to F dash 4F LV square, 4 LV square by d. So now we will have to compare both. We will have to compare both HF into rho g. HF into rho g is equal to F dash LV square 4 divided by d. So now basically we will have to find out HF. So what is equation of HF? 4. Now F dash L v V square divided by rho d g. Now here 4, let us make it as a single term, rho g L by d, and here we have V square by 2g. So here we are dividing it by 2g, so here we will multiply it with 2g, so g get cancelled. So and let us take this as a f, whole term as a f. So what will be the equation? 4f L V square by 2gd. So this is the equation for HF according to Darcy's equation. So according to Darcy's equation, if flow is taking place inside the pipeline, what is the head loss due to friction? So that will be 4f Lv square by 2gd. Now we should know that what is f. So equation for f will be this, but in our example f generally directly given, so no need to worry about this, but you should know that what is how to prove this equation. So thank you all for listening me.